GATE 2019 Civil Engineering Set 1 Question 48. Tie bars of 12 mm diameter are to be provided in a concrete pavement slab. The working tensile of the tie bars is 230 megapascal. The average bond strength between a tie bar and concrete is 2 megapascal and the joint gap between the slabs is 10 mm. Ignoring the loss of bond and the tolerance factor, the design length of the tie bars in millimeters needs to be found rounded off to the nearest integer. The relevant NPTEL reference has been listed. So when it comes to development length, one needs to refer to IS 456 clause 26.2.1. As per this clause, if we have a concrete slab in which we have fixed a steel bar and this is getting pulled with a force of T, so there should be a resistance developed by the concrete to strengthen this bar against the tensile force. Let us call this force as R, that is the resistance force. So for equilibrium or stability, T should be equal to R. The tensile force can be given by the stress that can be taken by the steel bar into the area of the steel bar, that will be pi into diameter square by 4. The resistance force will be a function of the bond strength. Bond strength is nothing but it is the force that exists between concrete and steel. So the bond strength will be multiplied with the circumferential area of the bar. So if this is the bar, it will have a circumference, and this circumference, on this the bond strength will act. So the circumference can be found out as pi into the diameter into the length of this bar that is inside the slab. This is called as LD, or the development length. So this is LD. So LD can be found out as diameter into stress of steel by 4 times the bond strength. So one needs to know about the concept of development length to solve this problem. In this question, we have been given that there are two slabs which have been joined using tie bars. So let us consider the two slabs. Here the joint gap is given in the problem as 10 mm. So we will connect these two slabs using the tie bars. So here, as we saw in the previous slide, this length should be equal to LD, this length should be equal to LD, so that the bars can be strengthened enough to hold the position. So the design length of the tie bars will be LD plus the gap plus LD. So it will be 2 times the development length plus gap. So in this case, as we saw, LD will be strength of steel into the diameter by 4 times the bond strength. So in this case, the strength of steel is given as 230, diameter is 12 mm by 4 times the bond strength is given as 2 megapascal. This would give the value to be around 345 millimeters. As we saw, the design length is 2LD plus the gap, so it will be 2 times of the development length, that is 345 mm, plus the gap that is given as 10 mm in the problem. So adding this, we can get the design length for the tie bars, that will come to be 700 millimeters. So tie bars of 12 mm diameter were provided in a concrete pavement slab. The joint gap was given and the bond strength of the tie bar and concrete and tensile stress of the tie bars was given. The design length of the tie bars was found out as 700 millimeters. The relevant NPTEL reference has been cited.